You move your mouse a few inches to the right, and the cursor glides across your screen. It feels effortless, natural, almost magical. But underneath that simple motion lies an incredible engineering story. In this video, we'll take you inside both mechanical and optical mice to reveal how they track your every gesture, from the rolling ball of the past to the high-speed cameras of today. Let's start with the classic mechanical mouse, the one with a ball on the bottom. When you drag the mouse across your desk, that rubber ball rolls in the direction you're moving. Inside the mouse, this ball touches two rollers positioned at a perfect right angle to each other. One roller tracks forward and backward movements which translate to vertical motion on your screen. The other roller tracks left and right movements which correspond to horizontal motion. As the ball spins, it turns these rollers. The more you move the mouse, the more the rollers spin. Each roller is connected to a wheel called an encoder. As the rollers turn, they rotate these encoders much like a car's axle turns its wheels. On the rim of each encoder are tiny metal contact points. Two contact bars extend from the mouse's housing and touch these points as they pass by. Every time a contact bar touches a point, it generates an electrical signal. The number of signals tells the computer how many contact points have passed. More signals mean you've moved the mouse farther. And by combining the signals from both rollers, the mouse can determine the exact direction you're moving. These signals travel through the mouse's tail-like cable into your computer. The operating system converts the frequency of these signals into distance, direction, and speed. And just like that, the cursor follows your hand's movement across the screen seamlessly and instantly. But mice aren't just for pointing. Tapping a button sends a signal to the computer, which passes it to the software. The scroll wheel between the buttons works similarly. It's attached to its own encoder. Want to know how a trackball works? Just turn a mechanical mouse upside down. A trackball is essentially a mouse mounted so you roll the ball with your fingers instead of pushing it across a desk. Now let's look at the modern optical mouse. No ball, no moving parts. Instead, it uses a tiny camera. And or in some high-end mice, a laser lights up the surface beneath the mouse. A digital camera peers through a plastic lens at this area and takes hundreds of photos every single second. The camera sees the surface in black and white, looking for microscopic patterns, tiny bumps, and textures. By comparing consecutive images, it detects how far and in what direction the pattern has shifted. These images are fed to a specialized microprocessor called a digital signal processor, or DSP. The DSP chews through millions of pixels per second, analyzing, comparing, and calculating movement. The calculations are then sent to your computer either through a USB cable or wirelessly via Bluetooth. The mouse sends reports on its current speed and direction 125 times every second. That's one update every 8 milliseconds. This incredibly fast reporting rate is why your cursor feels so responsive. Modern optical mice often come with extra features, side buttons for navigation, or even tilt scroll wheels. Whether it's a rolling ball or a tiny camera, your mouse translates hand movements into digital commands. Next time you guide your cursor across the screen, remember the incredible technology making it all possible. Thanks for watching. If you enjoyed this breakdown, hit like and subscribe for more tech explained in plain English.